Hey, 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 I'm back. Thanks for tuning in, and look, sorry I didn't get out my usual promo email. Yeah, it's been a bit of a chaotic week. In fact, I was going to have a special guest on today, and we were ready to record it, but just didn't make it. Little technical hitches. So it's going to be me, just me today, chatting to you guys. So please feel free to use the chat today. It's going to be sort of a bit of Q&A going on here, but I do have some content I wanted to present to you. So yeah, and also just let me know how the stream's going. I'm here in my little studio. It's hard to know what's happening sometimes. Oh, g'day, Gian. Gian says hi. See if I can bring that up on screen. Yeah, so hi, Gian. That's great to great to have you along again. You're one of my most regular viewers, so thanks. And sorry I've missed a few sessions because of birthdays, long weekends and stuff. But you know what? Today's Mother's Day and I'm here. So this is your Mother's Day present. In fact, a big shout out to all the mothers in the world who made it possible for all of us to be here. Yeah, fantastic to celebrate mothers. We certainly need them. Yeah, now... What's news? What's news? Well, it is Mother's Day. There's a bit of news there. And what else is today's kind of going to be about energy storage. Now, look, I did talk a bit about the battery rebate with John Grimes from the Smart Energy Council, and we talked about the federal government battery rebate today. But I'm going to talk about storage, but in a way you might not expect. But we'll also cover some of that stuff to do with the battery rebate as well. So there you go. That's the plan for today. And I really would encourage you to use the chat to ask questions, comment on stuff. It's great for me to kind of feel the vibe of the audience. Yeah, so let's dive into it. What am I talking about? Energy storage, but not in a way you think about it. Well, what if I was to say that for less than $1,000, you could have a 15 kilowatt hour storage system? And you might go, Glenn, that's way too generous. I don't think the battery rebate would be anywhere near that. If I was to say that you've actually got most of the components already installed on your home and you don't even realize it? You getting me? Guess what I'm talking about? Hot water. That's right. A hot water tank is an energy storage device. Typical usage in Australia is between 10 and 15 kilowatt hours per day. That's quite a big energy storage unit that you're draining and refilling every day. So what about putting renewable energy into that? That would make it a truly useful battery. That's just not just using grid power or off-peak even, but just using renewable energy. So there's been a lot of products in the market over the years that can do exactly this, that can store renewable energy or can divert it into your hot water tank. And I've got a whole pile of them here, which I'm going to show you. And they have different features. In many ways, even before you install a battery, if you have a resistive element hot water tank, you should think about doing this first, because actually you're taking the most advantage of a free storage device that just needs some enabling technology. And so we're going to talk about that enabling technology. But before I dive into that, I actually wanted to explain a bit of how they work. Now, there is some simple systems in terms of diverting, if you want to use that word in a very broad sense, energy into a hot water tank. One methodology is basically just to switch on the hot water tank whenever there is some surplus solar energy. But that brings with it its own little problems. And let's see if I can bring this one up for you. Here we go. So I'm going to sort of explain this with a drawing. Now, if you consider your energy graph here, so this is power, this is time across the bottom here, and let's just say that's noon, somewhere like this. There we go. That's noon. Now, I might kind of show my loads in a special way. So our loads are doing this. Nope. you might wonder why I'm drawing load energy like a square wave. It's because it's a certain type of appliance that has that characteristic. Okay, and that's morning peak. Now let's imagine this is a home where people leave, go to school, go to work, and then during the middle of the day, really not much is going on. Gee, I like drawing little square waves. There we go. But then in the afternoon, people come home, turn things on. There's some cooking being done maybe. It's a bit of a weird line, that one. And energy use tails off into the evening, and then we go back to just the fridge or standby loads. So there's your load profile. So we'll call this in brown loads. There we go. And on top of that, you've got a solar PV system. So let's say you've got 6 or 7 kilowatts of solar PV, and it's a sunny day, and it's going to produce a bell curve. Was that yellow's horrible, isn't it? Yeah, it didn't even work. I'll go for orange, something a bit more visible. So you've got a bell curve like this, and so this is your solar production. Now, what you can see from that is that most of the solar energy is above the load curve, which means it's either going to be curtailed because you've got an export limit, and that might depend on your DNSP, or it might be basically exported to the grid at a very low rate. So in Australia and New Zealand, New Zealand's a bit better off actually. They still have some quite generous export rates, but here in Australia, exporting is really just an unwanted energy for most of the day. So that's a terrible match of solar production to loads. Now there are things you can do to move loads into that centre portion, such as scheduling. So things like hot water controllers are one way of doing it, but another way is using things like the time delay on your dishwasher or clothes washer, etc. But a hot water controller can do it in a couple of ways. Now, here's one that's very popular in Australia. It's by a company called Catch Power, and this is their Catch Solar Relay. So it's actually a switch. It's got an output or voltage-free contacts that can control a contactor that can switch on something like a hot water service. And it can do it in a smart way. It can do it by time of day, by surplus energy levels available, by communication with the inverter itself. It's got Bluetooth for programming. They also have Wi-Fi connectivity, so you can monitor it through their Monocle app. And all of that by switching on an element. But you've got to consider, if I put some numbers on this page here, let's say that point there is 3,000 watts of power. So there's our 3,000 watt mark. Okay. Now, depending on your hot water service, your element might be 2.4, 3.6, even a 4.8 kilowatt element. But note though that that's at 230 volts nominal grid. So many parts of Australia, less common in New Zealand, but many parts of Australia are way above 230, more like 240, 245, which means that your 4.8 kilowatt element is way over 5 kilowatts when it's on, because more volts means more power. But anyway, there's our 3,000 watt line I've just drawn. And so let's say we've got our Catch Solar Relay here set to turn on your hot water service whenever there is more energy available as a surplus than your element can consume. And so it's trying to use the energy in this part as much as possible. But of course, as soon as you switch it on, you could risk that it's going to dip again, and that's why it's a smart controller. It's being aware of if you have an inverter connected to it, the inverter's measuring the amount of import and export or the amount of potential export, and can ensure that that hot water element is only switching on when it's got surplus solar. So let me kind of turn on the the hot water service here. So I turn on the hot water service, and here we go. And then I turn it off again. And so all of that is hot water heating. So that's under the curve of the solar. But it's not a perfect match to solar, but it's good. It's good enough. In fact, for a relatively low cost, can't remember what these are, but I think around the $500 or $600 mark. Anyone in the comments want to tell me what it is? I'm not very aware of current pricing, but to have that simple device, being able to use your hot water service as a 10 or 15 kilowatt hour battery is a very, very cost-effective solution. All right, so tell me if you think this is a good idea. You're all very quiet in the chat, right? So that's one way of doing it. Catch solar relay. There are other products on the market that do it in a more continuous way, and so this is a product also by Catch called the Catch Green. Now it's a bigger device and it's more expensive. I think it's a bit dusty, that one. Sorry, been on my shelf for a while. It's got some smarts as well. It's got some learning algorithms that learns about your use of hot water. But one of the things that's nice about it is it tries to divert only the surplus to your hot water service. Why is that a good thing? Well, as you saw earlier in this graph, I was showing the hot water service turning on all at once. Sorry about the focus there. I'll get that out of the way. But with a diverter, it can turn on progressively because it's it's not a switch. It actually diverts a proportion of the energy to hot water. So it will start to, as soon as there's some surplus, fill in this part here. And it'll fill in this part here until the tank has reached temperature. So this area here is a proportional diverter. So it diverts the can't even spell. There we go. Proportionally diverts the excess solar into your hot water tank, and not just switching it on or switching it off. So there you go. That's a big improvement, but it is at an additional cost. So I think something like the Catch Green is probably twice the cost of Catch Solar Relay, but it does you could say, a more excellent job of matching your surplus solar to your hot water consumption. Okay, so there's two. Now, I've also got some other products that have turned up here, and this one's from South Africa, and I'm actually going to do I've already recorded a video about this product with the lead engineer from South Africa, and let me open it up for you. It's got a really cute name. It's called the Hotbot. And the Hotbot from Plentify. This is a very popular product in South Africa because water heating is the biggest energy use in domestic. It's much similar to Australia, I suppose. Also, resistive element hot water services are very, very common. Now, it's got quite a few components in here. For instance, it measures the temperature through a little ribbon thermostat here. So it's actually measuring the temperature of the tank. You poke that into the tank. It's got a outlet temperature probe, which is rather clever. It pushes over your pipe and has a thermocouple here and plugs into the controller. So it's measuring the outlet temperature of your hot water service, the actual pipe. It's measuring the inlet temperature of your tank, and it's got a cable for bringing AC power to the device, and this is the device itself here, the actual hot pot. Oh, put those out of the way. Now these, I know the pricing in South Africa is around, I think $300 or even a bit less, $250. Okay, oh, geez, maybe I'm making it up. I better put it in the description, but it's pretty cheap actually. And inside here, gee, I should have brought a screwdriver with me, but inside here is where all of your sensors plug in and where your main AC power plugs in. And so it can use the information about your inlet temperature or outlet temperature and the thermostat temperature of your measuring the actual tank temperature by direct contact with the tank. And that's giving it a lot of information about how much hot water you're using, when you should be supplying it with electricity and when it's full and no longer requires that. But that's only half the story. So the hotpot itself has comms built in. So it's got a long range, I think they're using LoRa Wi-Fi because it's got like a 5-kilometer range. It's pretty amazing in this little product. There's an antenna built into this. I don't know where it is, but built into this unit. And it can talk to a smart controller called, and here's the next bit of the kit, called the Solar Bot. Now the Solar Bot is all about integrating with your inverter as well. And so the solar bot, very nice looking little unit here. There it is. So it's got ports for connecting to, it's got Wi-Fi and it's got its own long range communication mesh network system. So it can talk to multiple hotbots and can mesh with nearby hotbots within that 5-kilometer range. So certainly cover a home. It could even cover a commercial installation. And it's got ports here for various sensors and also for comms to the inverter itself. So it can connect to the Wi-Fi dongle port on many inverters. In South Africa, a brand called SunSync, which is also known as Doye here in Australia, very popular in South Africa, and they already integrate with SunSync. So it can use the inverter itself to understand its solar production and when to divert. So there you go. That's the Solar Bot. What else have I got here? And this is a part of a system from an Austrian company called MyPV. Now, I've actually got both the Catch Power solar relays, these things, dotted around my microgrid on various hot water services because I use these. I'll put that aside for a second. I use these in a special way because I'm running a off-grid microgrid. And in order to control things like when there is surplus energy on the microgrid, being able to dispatch that to a hot water service, I use the fact that the frequency changes on the microgrid when there's surplus power very slightly, and that triggers these Catch solar relays to turn on a sequence of hot water services. I think I've got 3 hot water services at different frequency switch points, and so they progressively soak up that surplus energy. So that's really cool. But I've also have a system from this Austrian company called MyPV. Now, this is their energy meter. The actual diverter I haven't got on my desk because it's actually installed on my home at the moment. And it's quite a big unit, but it's 3-phase. So it can do 9 kilowatts of diversion power. It can do single phase as well. They make a single phase unit. They make a 3-phase unit, which actually can split the phases. So you can use 3 separate phases for 3 different purposes. You might want to heat water. You might want to space heat. You might want to heat a boiler, if you have such a thing, any resistive element. And it does it using pulse width modulation. Now, I'm going to talk a bit about the ways that diverters work in a second. But yes, MyPV is a PWM or pulse width modulation diverter. And that gives you a very smooth sine wave, which is kind of nice. So no questions in the chat yet. You're a very quiet bunch, or maybe you've all gone away. Sometimes I feel lonely talking here. It's nice to know there's an audience. So let me explain how diversion works. And when I say diversion, I mean proportional diversion, not just switching on a relay or switching off. And there's really three strategies for that. So let's get my little black pen out. So we've got pulse width modulation, which is what I just described to you. And if I do a little graph here, and I should have done a center line, sorry. Let's do a center line. And we've got a sine wave, and the sine wave goes up like this, and down like this. So there's my best effort at a sine wave, all right? Now, if you want to divert power in a proportional way that matches the characteristic of a sine wave, you can do it by pulsing small amounts at high frequency. And that's what PWM is. So it's basically doing we're talking 10 kilohertz or more, so it's really high speed, but it's creating a sine wave in small amplitude, varying amplitude pulses. So we'll call this PWM, pulse width modulation. In countries like Austria, it's actually mandatory to use PWM for any systems greater than 200 VA of power capability. But that's not the case in Australia. We don't have that regulation. The other way, well, there's actually two other ways, is where, once again, do my little sine wave. Okay. But what we're doing now is interrupting the cycle. It's going like this, interrupt. Interrupt. Oh, actually, I started leading and a trailing, but normally it's either leading or trailing, not leading and trailing, but you're chopping up the waveform so that only proportion of it is actually being produced. So I should have done it like that. There we go. That's better. So that means that's diverting power, then there's a gap, then that's diverting power, then there's a gap, then that's diverting power. So that's phase angle. And the third way is known as burst fire. And I sometimes describe that as a bit like letting your child play with the light switch. So it looks like this. I won't even draw the previous sine. Oh yeah, I've got to. Let me draw a sine wave. So there's a normal sine wave, but with burst fire, we'll go one wave, then a pause, then another wave, then a pause. And the gaps can be on both the positive or negative side of the center point, but it just means that there's moments when the waveform is on and moments when the waveform is off, but it's always at a full partial cycle. So that's known as burst fire. Now, this might be a bit controversial, but there is some critics of these bottom two strategies that they do create a little bit of noise, and also in terms of power quality issues on the grid, and they also can kind of be more difficult for the utility meter to accurately measure power consumption. I haven't got any direct evidence of this. I just know that people on the Standards Committee have talked about it, and one researcher said there can be up to a 400% error factor with this type of waveform being measured by various types of utility meters. Now, whether that's in your favour or the utilities' favour is probably another question. But there you go. That's the kind of the three different strategies of modifying a sine wave to divert a proportion of its energy into a resistive element, and to give you the benefit of your hot water tank being basically a storage device. All right. Day asks, measure in whose favour? It's uncertain, is what I've been told. There are many different types of meters. They all have to meet a certain minimum requirement, 1% accuracy for utility metering, but they can use different modes to do that metering. And I think the impact can vary depending on what type of strategy that meter uses. So, yeah, I don't know in whose favour it is. There's probably a research project in this for anyone who's into understanding hot water diverters. I'd be very interested in knowing more about an outcome of that sort of research. So g'day, Dave. Thanks for asking that question. I've got a feeling I can pop you up on the chat somehow. Can I do that? I don't know if that's going to work. But anyway, I'm just playing with my software here to see if your question pops up on the screen. So where are we up to now? Yeah, that's kind of the basic methods, but there's some really simple ones too. Now, people are going to say, "Oh, what about if I've got a heat pump? What do I do if I've got a heat pump?" I've been told it's not a good idea to turn them on and off, which is true. So I should clarify my terminology, by the way. A hot water heat pump is what I'm referring to, something that uses the refrigeration cycle, which is a bit confusing with its name, considering it's going to heat your water, to capture free solar energy, which also seems a bit weird, but that free solar energy is the energy in the air around you. So if you're not familiar with how a heat pump works, it takes low-grade energy from the air and converts it to a higher temperature to heat water, or in the case of a reverse cycle air conditioner, to heat air. And it does that using the refrigeration cycle through compressing a gas and cooling it or heating and then releasing it again through a metering device. So yeah, that's kind of how a heat pump works. But because it's actually a compressor which has to pump gases around, it's not suitable for being switched on and off. It's very bad for them, I'm told. I'm not a plumber, so it's not my expertise. But yeah, you don't want to just be flicking your heat pump on and off. But there are ways to control heat pumps. Many heat pumps actually have the ability to connect to a cloud for monitoring and control. And cloud services can often offer an API, or an application programming interface is the acronym. Basically, it means that third parties can either read and write to that device. And that might mean remote control via the web of your heat pump hot water heater. Now, once you've got that functionality, it's possible to use relatively simple devices that can communicate with the cloud. And I've got one here from a Melbourne company called Deus. Now let's bring my little overhead back on again. So this is, it's probably better with white in the background. So there you go. Actually, no, it's probably with black. Okay, it's better with black. So this is Deus, and this is kind of the heart of it, is this little gadget here. Now, it looks pretty innocuous, right? It's got a rubber strap, and you go, Glenn, what's that for? Because it can be wrapped around a conductor. Now, this is designed as a device for measuring energy, but it can also communicate via locally via Wi-Fi with its own controlled socket outlets. So we've got a socket outlet here, and this socket outlet can talk to your Deus, and the socket outlet itself connects to your wireless network, so it's got a Wi-Fi transmitter in it, and it will update the Deus, which is actually the company's products called Power Sensor, so I'll call it Power Sensor Cloud. So that means that this is measuring consumption by being wrapped around a conductor, like on the output of your inverter, or even at your main switchboard, or even just in close proximity to your main service fuse. It's a pretty clever device. In the box, I haven't shown you the whole kit here, but in the box comes some mounting gear, so you can actually mount this next to your service fuse with no electrical connection to it, and it will then be able to measure the incoming energy. And there's several of these in the kit, so you put another one on your inverter's AC output. Once again, you can wrap this cable around it. It's got a rubber thing for wrapping around, or you can use Velcro tabs, and it's measuring the production of your inverter. Now, at this point, I should point out this is mainly about measurement and monitoring, but it can control, because you've got a socket outlet here with a 3-pin plug, and this can be turned on and off remotely. So just imagine it's effectively plugged in a heat pump in here. You could control it, but you don't want to just switch it on and off, right? So you probably want to talk to, or the device, talk to the heat pump's API and tell it when to cycle down and when to cycle up. So guess what I'm saying is there are other products in the market that can utilize the functionality of the cloud to control things like heat pumps. So yeah, Ray's asking. So it's a wireless contactor. There is actually switching inside here. That's right. So this device is also a measuring device. It measures the consumption on this socket outlet. So if you were to put these on, devices around your home that you want to measure, like your fridge or other 240 volt appliances, it can measure them. So that's pretty cool. Hey, good to have you back, Ray. You're off the boat again. So yeah, let's have a look at my list. I think I've kind of got a rather short program today, I think, unless I get some questions from the audience. Let's just have a little look in here. Now, by the way, I should mention that I was a little bit disorganized this week because I had planned to have a live chat with a special guest who hasn't been on the show before, but we had some technical problems with the recording. Fortunately, we were doing it as a pre-record and then being able to stream it on Toolbox Tech Talk, but we had some problems. So we're going to try again next week. So you might have my special guest back next week, with fingers crossed that we sort out our tech issues. Yeah. Now let's have a look at my schedule here. Hot water. Oh, yeah. The battery rebate. For those who've been under a rock in Australia, we've just had a federal election, bit of a landslide to Labor, and as a result of that, their pre-election promises of a very generous battery rebate for up to 50 kilowatt hour batteries on-grid, off-grid, residential, commercial, for the next 5 years, uncapped, already budgeted for $2.3 billion. They expect 1 million battery systems to be installed at least under the program. That's pretty exciting news, but the detail is yet to be written. So the detail is what's known as the regulations on how the program will be administered, and the fine details about, what are the conditions that you have to meet. So I think there's still a little bit of hesitancy in the industry to kind of rush out and start high-fiving each other. But what we do know is it's based on the SRES, the Small Scale Renewable Energy Scheme. So it's the advantage is they don't have to go through Parliament. It's just a regulation change for the SRES, and we'll be using the STC value that they attribute, which is 9.3 STCs per kilowatt hour of energy storage. And that works out on typical pricing of STCs at the moment around $360, $370 per kilowatt hour of battery storage. So it's pretty generous. For many systems, that'll cover probably, a third or more of the cost of a battery. So it's a very exciting program. But like I say, the detail isn't out yet. We're waiting for the minister to be sworn in for energy, and hopefully it's Chris Bowen again. He's done such a great job. And then the Clean Energy Regulator can go forward with completing the regulations and publish them. So if all goes well, on the 1st of July, this program will kick off, even though the minister himself, in a live briefing, which I did a review of a few weeks ago, did say you can sell systems now and install them now, but you just can't switch them on to the 1st of July to claim the rebate. Be a little cautious on that because we don't yet know what those regulations covered. So Jian's asking me what type of batteries are included. So currently it says that the batteries have to be on the approved battery list for the Clean Energy Council's approved product list, I should say. So basically it's going to be lithium-ion battery, but there's many, many choices on that approved list. And the capacities can be up to 50 kilowatt hours that you can get the rebate on, but you can install up to 100 kilowatt hours of batteries. So that means you can put a 100 kilowatt hour battery, and it's usable capacity. That's a very important note. So many systems are sold with a notional value, and then it'll say 90% usable or whatever. So it's the usable capacity it's all based on. That's good. So you could install a 100 kilowatt hour battery with, on the first 50 kilowatt hours, will get you around $18,000 of rebate. So woohoo, that's going to really unlock a lot of very large systems, particularly CNI, I expect. Not large CNI, but just larger systems for domestic and certainly for CNI, a modest size system. So my pick is that we'll see a lot of 50 kilowatt hybrid inverters going in with 100 kilowatt hours of usable storage, and an appropriate amount of PV being covered as well by STCs. So you'll be getting STCs on your solar, STCs on your battery. It's going to be a pretty sweet payback period. So yeah, that's exciting stuff. Okay, any more questions there? Like I said, you're a very quiet bunch. I can see there's about a dozen of you watching at the moment. Yes, Day, it does cover off-grid as well. There is a requirement for on-grid systems to be VPP capable, virtual power plant capable, but it doesn't actually have to join a VPP. So Day, I'm not sure what you mean by not in AusNet. So AusNet don't rule off-grid systems. Off-grid is its own entity. There's no DNSP for off-grid. You are the DNSP yourself. So I'm not quite sure what you mean there. Oh, g'day. Hi, Susie. Hopefully it's a sunny day in Mansfield today, though you probably want the rain. And happy Mother's Day, Susie. There you go. Yeah, so Dave, if you want to get back to me what you mean by not in AusNet. I know that there's been a lot of trouble in Victoria with the implementation of backstop program. Backstop's part of the methods to have a dynamic export control administered remotely. And Dave got back to me. Thanks, Dave. Dave says they want to limit the amount of grid-connected battery. Oh, fair enough. So, Dave, I understand what you're saying there. Maybe I'll bring out my little drawings again, because this can be a bit confusing. So I'd probably challenge you, Day, on that one, but I could be wrong, and I'll explain why. Now, there's a couple of ways that you can include battery storage onto an on-grid system, and one way is to have a DC coupled system. So here's our grid. There's our power pole coming from, in this case, AusNet, and it's coming through our main switch, and it's going to some loads in the house, like this. There's some loads in the house. Call that loads. And then we've got a connection to our hybrid inverter. Now, the terminology used in standards, by the way, is not hybrid, it's multi-mode. So I'll just draw. And we've got a battery connected to that. So that's a symbol for a battery. And we've got some solar PV connected to that. So there's our solar PV system connected to it. So that's PV, and that's battery. So that would be a hybrid system under what's commonly used, or multi-mode inverter, MMI is a more technical term for it. Now, in this scenario, what AusNet is concerned with is the amount of energy that you can pump out of this system, and they may limit you in terms of export limiting, or the amount of IES capacity per installation. And that's IES is the terminology used in the standard inverter energy systems, meaning single or plural inverters. Now, so if we've got we'll call this a 5 kilowatt inverter. So it notionally can pump out 5 kilowatts. Now, AusNet might say you have a 5 kilowatt or 5 kVA limit of IES capacity per single phase site. So this is a single phase connection here. And that would mean if you were to add another battery system to that and try to add it as an AC coupled battery, so we're going to put in another battery system here, but this one is just a battery with an inverter. So this is a let's say it's a 13.4 kilowatt hour battery with 5 kilowatts of AC output power. So it as well can output 5 kilowatts, but it's 13.4 kilowatt hours of storage. So your IES capacity now is 5 plus 5, 10 kilowatts of IES capacity. So that's what AusNet are limiting you to. But if you have a hybrid inverter, the size of this battery could be infinity. It doesn't have any impact on AusNet. So they're not limiting you per se on battery capacity, just the IES capacity of the site, the number of inverters. Now, it's not just unique to AusNet, by the way, but they are pretty tough. There are utilities that allow a bit more than that. So having 10 kilowatts in some areas isn't unusual. So I guess what I'm saying is if you've got an existing solar inverter, let's say we take the battery away, you've got an existing 5 kilowatt solar inverter with no battery, and you want to take advantage of the battery rebate and add, say, a 13.4 kilowatt hour battery with 5 kilowatt built-in inverter, you actually have doubled your IES capacity doing that, and you may be knocked back by some DNSPs as exceeding their requirements. What would be a better option would be actually just scrap. I know it sounds bad from an environmental point of view, but actually appropriately recycle, which probably means goes to e-waste, your existing grid tie inverter and replacing it with a hybrid inverter with as big a battery as you like. And that way you've still only got a 5 kilowatt IES capacity on the site, no matter how big the battery is. So there you go. I just realised some other item I want to cover, which is another video I'll be releasing soon, which is all about battery sizing for customers' various needs. So whether it's for most cost-effective solution, whether it's for days of autonomy, how much backup they want, whether it's the renewable component, how much renewable energy they are using in their installation, whether it be a business or a home. And that is quite a detailed presentation that Anne Wilson from Solar Plus has done with me. We recorded it last week, and I'll be releasing that onto the Smart Energy Lab channel later on. So there you go. That's something to look forward to for those who are into the more technical calculations around sizing a battery and looking at the economics of it, as well as the renewable energy quotient. So where are we up to? So that was me sort of answering that question from Day about why you may be limited on the size of the battery. It depends on how you connect it. This is great. Throw me some more questions. We're sort of coming to the end of this session, so now's your chance. Yeah. What else I've got to tell you about? I should mention that the next Toolbox Tech Talk will be Sunday next week, 18th of May, 1 p.m. And very hopefully I'll have my special guest as part of that show. So anyway, Alec. Oh, g'day, Alec. Thanks for the tech talk. Sorry for the appreciation. That's Alec from Central Coast, New South Wales. Great to hear from you. Yeah, so I think they'll call it a day or a session. So thanks for watching another Toolbox Tech Talk, and see you next week. Okay, and that's it. We're out.